You're going to need a calculator today, by the way. Grab one if you don't have one. Anyway, to make sense of how what we're doing today is connected but not directly on the quiz, our quiz is technically focusing on sections 9.4 and 9.5, which is focusing in on solving for sides and angles using trigonometry. Now, in all technicality, in what we're doing today, we're going to be doing a lot of trigonometry. So, if we're still trying to make a little bit of sense of trig, some of the stuff you're going to see that are on the quiz, we're going to be reiterating some of those things today. But today we're focusing in on something a little more specific with our trig, which is known as solving right triangles. And we're going to skip over this first section. It's not necessary. As you've been going through and using trigonometry, you've been solving for certain aspects of a right triangle. But today, you're going to be asked to solve the triangle. Now, to quote-unquote solve a triangle, that means not finding a single missing piece, but finding all missing pieces on triangles. So now, when I ask you to solve a triangle, I am looking for you to tell me every missing side length and every missing angle measure. So essentially, it's still using the same things we've been doing. I'm just asking you to solve for more things. So it really does have connection with what we've been doing, but on the quiz, I don't need you to solve for all the things. I'm just asking each triangle for you to solve for one. Now, when it comes to solving a triangle, one of the things you actually have to know is when it comes to trig specifically, labeling a triangle looks a little bit different than it has looked prior in geometry, which you've probably noticed a little bit as things like if I talk about this triangle here, this just triangle ABC. In geometry, if I asked you to name this thing up here, you would have called it angle A with the angle symbol. But in trig, we just call it capital A. It's still talking about the same thing, but it's different notations for geometry versus trig. Side lengths also have different notations. In geometry, a side name or a side name would be like AC. In trig, this is side lowercase b. In labeling triangles in trigonometry, one of the things they do is they use the same letters for angles as they do sides. The difference is if they're capital letters or lowercase letters. Angles should always be capital letters. Sides should be lowercase letters. And for their naming, angles and sides across from one another have the same letter. So, letters across from one another on the triangle should always be the same. Hence the reason this was side B, because across from it was angle B. This is angle A, across from it is this side, that should be side A, and it's lowercase for a side. That's angle C, this is side C. Okay? Slightly different triangle here, also known as triangle ABC here. That's angle A. Which one is side A? The horizontal, the vertical, or the angled?
Vertical.
The vertical is side A, lowercase. Angle B is here. Which side is side B?
The flat one.
AC or the horizontal one, which means this is side little c. Okay, this triangle, angle X is here, meaning this must be side X. side y is here, which angle is angle y?
Angle y is the one on the right.
One on the right side. And that makes this one angle capital Z. So far, nothing too scary?
Not very scary.
Very scary? Okay. This is Jacob's level of fear. Naming sides with single letters. Got it. Okay. Now when it comes to solving a triangle, we have multiple tools in our advantage. We have trigonometry and inverse trigonometry, but we've got some others as well. If we want to solve for side lengths, yeah, we can use trig. Or, if you know two sides and are looking for the third one, what are you using?
The one with the square, whatever it's called.
Pythagorean theorem. If you're solving for angles, on the other hand, now, solving for angles, yes, you're technically doing trig, but more specifically for angles, it's what kind of trig? There's an I in the word. Inverse trig. So you do trig, but you specifically focus on the inverse trig. Or, if you know two angles and want to find the third, nope, Pythagorean theorem is a side leg thing. Oh, come on. This is 20-degree angle. What's that one?
That's 45.
70. I heard someone say it. How'd you come up with that?
Because it's 90 or 180 minus 90 minus 1.
Because angles in a triangle have 180-degree sum.
Indeed.
Technically, it's the triangle angle sum theorem. The key thing, add to 180, just like Pythagorean theorem. If you don't know its name, that's okay. It's a squared plus b squared equals c squared. So, those are the tools that we get to use. So, I'm going to flip the page. We're going to solve triangles. Solve the following triangles. Round angles to the nearest degree and sides to the nearest hundredth. Yes.
We're going to take a test after lunch. For our quiz. I feel like you already said this after that.
Indeed, Chase.
Per chance.
I believe I did, but if I didn't, that's okay. Quiz is after lunch. So, anyway. Okay, so we're going to solve this triangle, which means we are finding all missing sides and all missing angles. What's the name of the missing side?
Hypotenuse.
Little c.
It is the hypotenuse, but I was going for little c. But we are going to need to know that it's the hypotenuse, so good eye. Okay. Now, when it comes to solving this, I don't care what order you solve for things in. You can find angles first, you can find side lengths first. It really doesn't make a difference. You just kind of have to make a choice. I personally always go for the third item that I have two of first. And the reason I do that is because if I know two items and I'm looking for the third of that same item, I know I'm not doing trig.
That's facts.
That's the situation where I know I'm not doing trig, because trig always works with sides and angles together. So if I'm working with just sides, I don't have to think about the fact that, okay, I'm working with just sides. Is it opposite, adjacent? No. I just have to say, okay, on this one, I know two side lengths. I'm going to look for the third side length. And if I'm connecting three side lengths, is that Pythagorean theorem? In Pythagorean theorem, it goes a squared plus b squared equals c squared. But be careful. This a squared, b squared, and c squared do not necessarily match up with this a, b, and c. Sometimes it will, sometimes it won't. Which of these letters am I picky about in the theorem? C has to be the hypotenuse, which, as Jacob pointed out, is the same thing anyway. So, 2 squared plus 3 squared equals C squared. If I want to do Pythagorean theorem, I square the things. 2 squared is?
4.
3 squared is?
9.
I add them together. 9 plus 4.
For change 13.
13 is C squared. To get rid of the squared, I take the square root.
How about Jacob?
Now, is this a side length or an angle?
This is the side length.
So I'm rounding to the nearest what?
100.
100th. How many decimal places is that?
That's
Two.
the second one.
2 decimal places. So I go to my calculator. I type in the square root of 13. 3.61.
Yeah, math moment. Switch.
Sweet. One thing solved for. What else do I need to solve for yet, though?
Angles.
Which angles?
Round angles. Angle B and angle A.
B and A. B and A.
Let's go.
Okay. Now, when it comes to which one to solve for, you just got to make a decision. Which one?
A.
I heard more A's, so I'm going to go with A. Now, if I'm going to solve for A first, that means A is going to be my angle of focus for recognizing opposite, adjacent, and hypotenuse.
Yes. Is it? Wouldn't it just be 90, 30 since the two sides are different?
The two sides being different doesn't mean it's 30, 60, 90 triangle. That's a specific triangle that has different side lengths, but that does not, just because there's two different side lengths on it, it guarantees it's not 45, 45, 90, but it does not make it a 30, 60, 90. So, A is my angle of focus. If A is my angle of focus, 3 is what side?
Lowercase
It is lowercase a. That's not what I was going for. I was going for opposite this time. I know, you did the opposite this time.
I had
That is the opposite, making 2 the adjacent. Now, I know the opposite, the adjacent, and the hypotenuse now. Which one should I probably not use?
Should probably not use the hypotenuse due to its decimal.
Probably not use to the hypotenuse due to its decimal, and more specifically, actually, because we had to round to get that answer.
So it's not exact.
So it's not exact. Okay, so opposite and adjacent. What's the memory tool for trig? How do I spell it?
S-O-H-C-O-A.
Then T-O-A.
It's almost like it's written behind me still.
Oh yeah.
Yeah, that needs to go. But anyway, so opposite and adjacent is tangent.
Toa.
Tangent of
A.
A. Always of the angle. In this case, we don't know the angle's measure. Equals
3 over 2.
3 over 2. Nope. And even if it did, we didn't need to simplify the fraction to do our next step. How do I get A alone? Inverse. To try to get at the angle, to get rid of the trig without moving the angle with it, you do inverse trig. Death to both of those. A is left. A is whatever tangent inverse of 3/2 is. What are we rounding to?
56.
It's an angle, so the nearest degree, so 56. Don't forget the degree. And that is capital A. If you tell me that is lowercase a, you are telling me that this side length is 56. I hate to break it to you. That side length is 3, and we were given that in the beginning. Okay. Am I done? No, I'm still missing an angle.
Angle B.
Missing angle B. Now, do I want to do trig again?
No.
No. Because I know two angles. If I know two angles, how do I find the third?
You can just subtract.
Triangle angle sum theorem. In other words, triangles angles add up to 180. 180 minus the 90 minus the 56. Angle B is
34.
34 degrees.
No, I get that. No, you don't. Yes, I do. Sure. Stop
You
being
go.
rude.
You noticed it's very, 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 very similar to what we've already been doing.
Proud of you, Diego.
I actually think I'm gonna do it on
Try problem B.
babies later. How do we get Z alone? Reverse side of it, and you round it a little bit off there. So that's what we have to check. Sound the first down. Which rounds to how many degrees? Here's where you're getting mixed up. Why is not 100 or is not 7 degrees? You used Pythagorean theorem to solve for x, and that was 7. I'm not sure where this 100 is coming from.
It's not six.
So, let's make sure this is
You had one side of X.
is 50 y, and it's 7. Okay, this is, so this one is 7 degrees. Angles are trying to add up to 180 times the number.
What are you supposed to round angles to?
This is the hypotenuse, and this piece is here in projection to. That should be 25, and this should be X. Your song for angles are good. It's up, good. This is the hypotenuse, that's the piece that goes on the Don't see why you got something because you should have had then you did but it should be X.
What's the missing side length's name? X.
X.
How do I find it?
Great question.
Pythagorean theorem, because if I know two sides to find the third, I use Pythagorean theorem. In Pythagorean theorem, a squared plus b squared equals c squared. I'm picky about c. Which one has to be the c?
25.
25, because it is the
Hypotenuse.
hypotenuse. When I start hippopotamus, my goodness. When I start doing Pythagorean theorem, I need chewed-out cards with how I do this. I get this. I square them. What comes next? Subtract the 576. You get x squared is 49. To get rid of the squared, you take the x is 7. I chose to solve for x. If that is x, that makes this the adjacent and the hypotenuse. If you focused on solving for z first, your adjacent and your opposite are backwards. I chose to solve for x first. If I'm choosing to solve for x first, adjacent and hypotenuse goes into cosine. To solve for x,
Inverse cosine.
inverse cosine both sides, and I get 16 degrees. To find the final angle, angles of a triangle add up to
180.
180, so I do 180 minus this. Now, the last thing you're going to see.
Couldn't we also have done like tan or sine, or tangent and sine on that?
Yes, you could have chosen any option to do on that one, especially since you didn't have to solve for or round the side length. Okay, sometimes you're going to start in a situation where you're given an angle and a side length and you're told to find all the other things. Really, you're doing the same process. What's this side length's name?
H.
Lowercase h. This one?
G.
Lowercase g. I know two angles, so the easiest thing to find first is the missing angle. Angles of a triangle add up to
180.
180. If I take 180 minus the 90 minus the 25, G is a
65.
65-degree angle. From there, I want to solve for the side lengths. Do you want to find G or H first?
G.
G, sweet. Loving it. Now you need to choose an angle of focus, one of the acute angles. Doesn't matter which one, I'm going to choose the one they gave me in the first place. This is the adjacent. This is the opposite. This is my hypotenuse. If I'm going to solve for G, I'm going to ignore the opposite because I don't know anything about it other than its name is H. Adjacent and hypotenuse.
Oh, that would be C. So it'd be cos.
Cosine. What follows cosine?
H. Oh.
The angle
Yeah.
equals,
Good try, Chase.
is it G over 13 or 13 over G?
It's
Uh,
G over 13.
G over 13 to solve for G.
We're gonna times by 13.
Multiply by the denominator. Always the denominator. Hey, sweet, G is alone. So I type it into a calculator. 13 cosine of 25 is rounded to the nearest. This is a side length, so rounding to the nearest what? 100th. 11.78. To solve for the final side length, you have options to work with trig or to work with Pythagorean theorem. I personally would choose to do trig. 1, I prefer trig. 2, to use Pythagorean theorem, I'd have to use a rounded answer. So I would probably do trig. If I did trig, I would probably then use sine of the 25 degrees equal to h over 13, multiply by 13. Is it?
We're supposed to get out at 47 today, approximately, for lunch.
You're right. It's a good thing notes are done.
48.
So that's where we're stopping. My bad. Enjoy your lunch.
Lunchtime.